Now in yesterday's assignment problems, any doubts?
Sir, one doubt, sir.
Yeah.
Last ninth question, sir.
Yeah, tell.
1 by
Sir,
root
ninth question.
1 by
1 by root over n log n.
1 by root over n log n. Summation n is from 2 to infinity, correct?
Yes, sir.
Okay. Now say this problem. Here, what is the nth term? This is 1 by under root of n into log n. N into log n. If I choose I will tell generally what we do actually 1 by n power 1 by 2 and 1 by under root log n, right? If I choose this as Vn, then Un by Vn will be what? Un over Vn is equal to what? 1 by under root log n as n tends to infinity. As n tends to infinity, what is this? 0 you will get. And what is this sigma Vn series is divergent. Sigma Vn series is divergent. Okay. Sigma Vn series is divergent. And what is our limit comparison test condition? If limit Un by Vn is equal to 0, when limit value 0, definitely sigma Vn must be convergent. Sigma Vn must be convergent. 0 and convergent, then sigma Un also converge. Then sigma Un also converge. But what is this case here? Here sigma Vn is diverge and limit value 0. So we don't have any conclusion from this. So alternate is by observation. Okay, this is the idea where there is no conclusion from this one. Now by observation we have, see, one can write log n is always less than n for all n greater than or equal to 2, right? Log n is always less than n for all n greater than or equal to 2. This implies what about root log n is also under root log n is also less than under root n for all n greater than or equal to 2. That implies what is this becomes 1 by under root log n. Now it is greater than 1 by root n. Since we are interchanging taking denominator, the sign will be changed less than to greater than, and let us multiply on both sides by root n. So this becomes 1 by n log n is greater than 1 by root n into root n. Root n into root n. Okay, this is n. This is true for all, and this is my series un. And assume this series as vn. Un greater than vn, where here un is greater than vn for all n greater than or equal to 2, where vn is what series? 1 by n. That implies sigma vn is what? Sigma 1 by n. What is this series? Divergent series. What is this series? Divergent series. P value 1. P value 1. Therefore, using, okay, let me write in the next then. Therefore, using what is the second test? Comparison test 2. What is the statement of comparison test 2? Un and vn are both positive term series, and un is greater than or equal to k into vn. K value is here what? 1. K value 1 for all n, and the right side series sigma vn is divergent, then sigma un also diverges. Sigma un also diverges. Okay, this is the problem. Any doubts? Same logic, same problem, sigma 1 by log n. You can do this. N equal to 2 to infinity. What is the answer here? Solution n equal to infinity. Same by observation we cannot apply directly limit comparison test here. By observation we have log n is always less than n for all n greater than or equal to 2. Okay, so 1 by log n, 1 by log n is greater than 1 by n for all greater than or equal to 2. This is un and greater than this is vn, k value 1 here. So obviously, since sigma 1 by n or sigma vn equal to, since sigma vn equal sigma 1 by n is divergent by using comparison test 2, sigma un also diverges. Sigma un also diverges. Is that clear? Any more doubts in assignment problems? Hello? Any more doubts? Say this problem, one cube root problem is there. What is that? Summation cube root of n cube plus 1 minus n. Minus n. Yes?
Yes.
See what is here? Un equal to cube root of n cube plus 1 minus n. Okay. Actually, you have to find here rationalizing factor for this cube root. Cube root of a minus cube root of b. For that means a to the power of 1 by 3 minus b to the power of 1 by 3. We have to find rationalizing factor. It was somewhat difficult. So the another alternate way is one can write this as n cube plus 1 whole to the power of 1 by 3 minus n. Right? That is equal to, take n cube common outside. This is outside, it becomes n. 1 plus 1 by n cube whole to the power of 1 by 3 minus n. N into 1 plus 1 by n cube whole to the power of 1 by 3 minus n. Now this is equal to n into, see, I'm giving expansion. You know binomial series expansion. Anybody? 1 plus x whole power n expansion. 1 plus x whole power n expansion. Series 1 plus
1 plus
nx plus
n
n
into n
into
minus
n
1
minus 1 by
into
factorial
factorial into x square.
x square by factorial 3x cube and so on. This is series expansion. Now let us apply that series expansion here. This is 1 is here and this is x. 1 plus x whole power n. N value is 1 by 3. So let me apply this. This is 1 plus nx, n value 1 by 3, x value 1 by n cube, plus n into n minus 1 by factorial 2 x square. X square means 1 by n cube whole square and so on. Okay, this is series expansion and minus n. Minus n is there. Okay, the next step is, this is since expansion. N into, this is 1 plus 1 by 3n cube plus, what is this? You will get what? 1 by 3 minus means minus 2 by 3. So this becomes minus 2 by 9. 9 into this 18. Okay, 9 into 2, 18. And 1 by n power 6 and so on. This is minus n. Minus n. Now in entire this one, take n common. In entire this one, n common. 1 plus 1 by 3n cube minus 1 by 9n power 6 and so on. And what is this becomes finally minus 1. Here this n common and so on. This is infinite and the last term minus 1. So this plus 1 minus 1 gets cancelled. Plus 1 minus 1 gets cancelled. And now take in 1 by n cube common. So this term gets cancelled. So remaining part is n cube common means what? 1 by 3 minus 1 by 9n cube and so on. So this is equal to, so what is un value? 1 by n square of 1 by 3, 1 by 9 n cube and so on. So choose Vn equal to 1 by n square. That is sigma Vn is what? sigma 1 by n square is convergent series. Because n power 2, p value 2 greater than 1. Now, what is the limit value? Limit un over vn, limit n tends to infinity means un 1 by n square gets cancelled, un by vn. For the remaining part, the limit is applicable. That is 1 over 3, 1 over 9 n cube and so on. So what is the limit value? 1 by 3 not equal to 0 and finite. Therefore, by using limit comparison test, since sigma vn is convergent, sigma un also converges. This is the problem. Cube root of n cube plus 1 minus n. Any more doubts?
Sir, I have a doubt, sir. Hello?
Yeah, tell.
Sir, in second question, can we just neglect the terms which have numerator 4?
Please, can you read out the second question?
3 by 5 plus 4 by 5 square plus 3 by 5 cube, so on, sir.
3 by 5
plus 4 by 5 square.
Where is the problem? 3 by you tell 3 by 5 plus
4 by 5 square plus 3 by 5 cube.
Yeah.
And so on, sir. 4 by 5 power 4. Now in this question,
so
can
5
we
power 4 and so on, right?
Sir.
In
this question, can we neglect?
This is somewhat. No, not like that. See, this is a somewhat different problem, but easiest problem in a different way. See, what is series sigma un equal to?
GP.
No, how it is GP? No.
Separate the terms, sir. 3 terms and 4 terms.
It is not GP.
No, sir. 1 by
5 plus 3 by
See,
multiply 1 by 5 and subtract
just listen.
again.
No. Listen. See, this series is having somewhat zigzag terms, right? So what I'm considering the series as odd terms, these terms together. 3 by 5 cube. Next term is what? 3 by 5 power 5 and so on. Plus the next these, that is 4 by 5 square plus 4 by 5 power 4 and so on. Okay, this is sigma un. That implies sigma un equal to, let me consider this series as some an and this series as bn. One series an and bn, where sigma an is what series? 3 by 5, 3 by 5 cube, 3 by 5 to the power of 5 and so on, is in what? GP. With common ratio. What is that? R equal to 1 by 5 square. Means less than 1, right? Is it correct?
Yes, sir.
Is less than 1. Therefore, sigma an is what? As per geometric series test, converges, right? Convergent. Similarly, what is sigma bn series? 4 by 5 square, 4 by 5 power 4 and so on, is also in GP, with common ratio, what is here also? 1 by 5 square, less than 1. Therefore, sigma bn is convergent series. And see, both the series are convergent, since the condition is sum of two convergent series, not only two, more than two also. Sum of two convergent series is always convergent. Convergent means what? Tending to unique value. Okay, sum of two convergent series is convergent. Sigma un is, what is that? Sigma un I have taken as an plus bn is also convergent. This is the model. And remember, Sum of convergent series always converges. Sum of divergent series always diverges. But sum of convergent series and divergent series, no conclusion. Sum of convergent and divergent series, there is no conclusion. Sum of convergent series always converge. Sum of divergent series always diverge. But sum of convergent and divergent series having no conclusion. Yeah. Any more doubts?
Sir, third question.
I think. What is that?
Sir, in second question.
Yeah. Yeah.
In second question, we can multiply to the series 1 by 5 and subtract from the above series. We get GP with minus 1 by 5, sir, directly.
What? Come again?
If we take that UN as a series and we multiply 1 by 5 to the UN and subtract that 1 by 5 UN with UN, we get 4 by 5 UN. We get a series with minus 1 by 5 as ratios, common ratio.
Then what is that series is sigma un?
We can send that 4 by 5 to that side, sir. If we multiply
Yeah.
5 by 4 to convergent,
No. I
it is
cannot
convergent.
understand. You tell what is that? Un is what? You are multiplying un by what?
1 by 5.
1 by 5 means you will get this as 3 by 5 square, right?
Yes, sir.
4 by 5 cube, 3 by 5 power 4, 4 by 5 power 5 and so on. Next.
With this, subtract from that one.
What is the next?
Original one. From original one, we subtract this.
This is un you have taken.
No, sir. This is 1 by 5.
Okay, un minus 1 by 5 un.
Yes, sir.
So you will get 4 by 5 un.
Yes, sir.
That
is 3 by 5.
You get 4 by 5
plus
un. What you will get?
3 by 5 plus. First term, if we neglect 3 by 5 plus 1 by 5 square. 1 by 5 square.
Which one neglect? Which one?
First one, sir. 3 by 5, let it be there only. You add from second term, you subtract, sir.
No. Remember, see, you are multiplying the given series by 1 by 5, original series by 1 by 5, and in the original series, you are neglecting this first term, right?
Not like that, sir. Yes. In first
you just do it and WhatsApp me. Okay.
Okay, sir. Okay.
You do it and WhatsApp me. Okay. We will discuss. Right. Okay.
Okay, sir.
Next one. What is the third one doubt?
Sir, in the previous question, sir.
Second one.
Above one, sir. Which we applied binomial, no, sir.
What?
Binomial expansion you applied, no, sir.
Yeah. This problem.
But then we can do in other way also, no, sir, by applying a cube minus b cube formula.
Yeah, not a cube minus b cube. A power 1 by 3 minus b power 1 by 3. You find the rationalizing factor for, see, this term is there, na? This term. Okay,
Yes,
just I'm doing, don't do in exam. This can be taken as n cube plus 1 whole power 1 by 3 minus n cube whole power 1 by 3, correct? This n can be written as.
Yes, sir.
Right? So this is of the structure a power 1 by 3 minus b power 1 by 3. You find the rationalizing factor for this. Rationalizing factor for this. I have given one problem. What is that problem? Under root n square plus 1 minus under root n square plus 1 minus 1. Something problem is there, na?
Yes.
I think n power 4 plus 1 and n power 4 minus 1, correct? Right? This is the problem un. For this problem, you know root a minus root b. What is the rationalizing factor? Root a plus root b. So multiply this by n power 4 plus 1 plus n power 4 minus 1. Okay, and the same thing. Okay, then n power 4 gets cancelled. You will get constant in the numerator. So this becomes what? Something 2 by, I think 2 by what you will get? N power 4 plus 1 plus n power 4 minus 1. This is un. Then take n power 4 common outside, completely in the denominator. Okay, same logic is applicable for this problem also. This one, n cube plus 1 whole power 1 by 3 minus n cube whole power 1 by 3. You find the rationalizing factor for this. Okay. Then you multiply and divided by with that, then it will come in the denominator. You will get only n terms. Obviously, you will get Vn as 1 by n square, definitely.
Can we do that method in exams, sir?
Okay. Yeah, you can do. It's good. Right, it's right. You can do.
Sir, second question.
Sir,
Fill down. Okay. Come on.
Sir, second question. Can we remove 4 by 5 square all of those terms, sir? Because it remains unaffected, no, sir. Whether it is convergent or divergent.
No. You see. If we remove all the 4 by 5 square, 4 by 5 power 4 terms, those are in infinite, no?
Yes, sir.
We can remove only finite number of terms, not infinite number of terms.
Okay, sir. Thank you.
sir, if we do like 3 by 5 raised to n, so for the second question itself, if we do 3 by 5 raised to n for odd terms and 4 by 5 raised to n for even terms, and solve separately for two different cases, can we do that?
Yeah, I did like that only, no?
No, so like I didn't do like sigma an plus sigma bn. I did like separately, and my vn was only like my vn was 1 by 5 raised to n.
1 by 5.
Okay.
No, not like that.
Okay, sir.
Don't do like that. Okay, right. Now the next test is integral Cauchy integral
Sir,
test.
I have a doubt in question number 3.
Integral. Arre Baba. Yeah, come on. This one, na?
Sir, no, sir, third question.
3. What is the question?
Sir,
Yeah, what is the question? Tell.
1 upon 1 square.
1 upon
1 square
1 square
plus 1 plus 2 upon 1 square plus 2 square plus 1 plus 2 plus 3.
Right?
Yes, sir.
Okay, I'm solving. See, nth term. See, in the first term, this is the term. In the first term, what is the structure? Numerator value 1 and denominator value 1 by n 1 square. In the second term, numerator is 1 plus 2 and denominator is 1 square plus 2 square. Similarly, in third term, 1 plus 2 plus 3 and the denominator 1 square plus 2 square plus 3 square. So in the nth term, this is the nth term. What is the nth term? The numerator will be 1 plus 2 plus 3 up to n by denominator will be 1 square plus 2 square plus 3 square up to n square. Is that clear?
Yes,
okay.
Sir.
And what is the sum of the n natural numbers formula? 1 plus 2 plus up to n into n plus 1 by 2 whole by sum of the squares of the first n natural numbers formula n into n plus 1 2n plus 1 by 6, correct? Right? So this n plus 1 gets cancelled and this is 2 3s are, so the remaining term is 3 by 2n plus 1. This is un. Un value is what? 3 by 3 by 2n plus 1. Now take n common in the denominator. 2 plus 1 by n. This is 1 by n. Okay, I will write like this. 1 by n. So this my 1 by n is Vn. Un equal to this. Choose Vn equal to 1 by n. So sigma Vn is what? Sigma 1 by n divergent. Is divergent. Therefore, what is the limit of un upon Vn? That is equal to, always n tends to infinity. Un upon Vn is what? You will get limit for what term? 3 upon 2 plus 1 by n as n tends to infinity. So what is this value? 3 by 2 plus 0, 3 by 2, not equal to 0 and finite. Therefore, by LCT, what is sigma Vn divergent? Sigma Un also divergent. Clear?
Yes, sir.
Yes? Hello? Okay. Now I will go for another test. This is integral test. Integral test, or sometimes it is also called as Cauchy integral test. Cauchy integral test. The statement is let sigma f of n, not un. This is what sigma f of n means. F of 1 plus f of 2 and so on plus f of n plus f of n be a positive term series. Be a positive term series. Be a positive term series such that f of n is decreasing function, or you write like this: f of n is decreases as n increases, then the series sigma f of n and the integral 1 to infinity, this is n is from 1 to infinity, integral 1 to infinity f of x dx converge together or diverge together. This is the statement of Cauchy integral test, and the note is integral 1 to infinity f of x dx converges equal to finite value, then integral 1 to infinity f of x dx converges. Integral 1 to infinity f of x dx is infinite, then integral 1 to infinity f of x dx diverges. Now see the statement. I will explain the statement. Remember, here the series is sigma fn. Here the series is sigma fn. Why it is giving like this? Okay. Series is sigma fn equal to sigma fn is positive term series, that is f of 1 plus f of 2 and so on, and such that what is the condition? F of n is decreasing function. F of n is decreasing function. F of n is decreasing function means what? That implies f of, as n increases, f of 1 is less than f of 2, less than f of 3, like that. It is a decreasing function. Just wait. Decreasing function means what? This must be greater than. F of 1 is greater than, f of 2 greater than, f of 3 and so on. This condition must be valid. This condition must hold to apply integral test. Remember, f of n must be decreasing function. And observe this. What is this? Sigma f of n. This is my series. It is taken as here sigma fn is the series, and what is the integral? In place of f of n, in place of n, you put x, and integration with respect to x, and limits are 1 to infinity. When summation is from 1 to infinity, limits must be 1 to infinity. These are the assumed conditions. What is the first one? F of n, sigma f of n must be positive term series. Second condition, f of n must be a decreasing function, compulsory. Decreasing function as n increases, then you assume this function f of n as f of x. Just replace n by x, that's it. And evaluate this integral first. integral 1 to infinity f of x dx. Evaluate this integral. If the value of this integral is finite, then integral is convergent. When integral convergent, this series is also convergent. Sigma fn series is also convergent. When the integral value is infinite, then the series 1 to infinity f of x dx is divergent. When this divergent, the given series also divergent. This is integral test. This is integral test statement. Statement is very important. Now see, I think previously we did one problem. What is that? Yeah, you take this problem. For example, summation n equal to 2 to infinity 1 by n log n. 1 by n log n. Okay. Now till now you know how many tests? One is geometric series test, right? Another one is p series test. Next one comparison test, 1, 2 and limit comparison test. Now integral test. Okay. Now this is not geometric series. This un equal to what? This is n log n. This is not geometric series, not in the form of 1 by n power p. And coming to comparison test, let me choose. If I choose vn equal to what? If I choose vn equal to 1 by n, then sigma vn is what? Divergent series. Sigma 1 by n is divergent. But what is this limit of un over vn value? This is 1 by log n you will get after cancelling 1 by n terms. This value 0. Limit value 0, but series is divergent. There is no conclusion. What is limit comparison test? Second condition, if limit un by vn equal to 0 and sigma vn is convergent, then only sigma un is convergent. But here limit value is 0, but sigma vn is divergent, therefore no conclusion. No conclusion by limit comparison test. No conclusion by limit comparison test. Okay. Now, since now you know the integral test, see here, what is my function f of n? This is, take this as f of n, 1 by n log n, 1 by n log n. This implies, what is f of x? 1 by x log x. What is f of x? 1 by x log x. And what is the function? This 1 by f of n equal to 1 by n log n is decreasing function, as n greater than or equal to 2. Is it correct? Let us check. 1 by 2 log 2. Definitely it is greater than 1 by 3 log 3. Definitely it is greater than 1 by 4 log 4, right? Is true. So 1 point, decreasing function is finished, right? The first condition, decreasing function is finished. And what is f of n value? 1 by n log n. Just replace n by x. That's it. Now let us calculate the integral. Now what is integral? Integral f of x dx. Integral f of x dx. But what are the limits? Not 1 to infinity. It is 2 to infinity, because in the problem it is given as n equal to 2 to infinity. Okay. So limits are 2 to infinity. Then this becomes 2 to infinity 1 by x log x dx. 1 by x log x dx. Then what is this? Can be taken as 1 by 2 to infinity 1 by x by log x, isn't it? 1 by x into log x. And what is the log x derivative? 1 by x. It is there in numerator. Therefore this is what, after integration you will get log of log x. Log of log x between what limits? 2 to infinity. That is implies first one upper limit infinity, lower limit log of log 2. Anyway, what is this value? Infinity. Therefore integral 2 to infinity f of x dx is divergent. When value of the integral is infinity, divergent. Value of the integral is finite, it is convergent, divergent. Therefore you write like this: by integral test, sigma fn, that is equal to, what is the series? Sigma 1 by n log n equal to 2 to infinity, also divergent. Any doubts? Simple problem to understand the concept of integral test. Any doubts? Right? I will tell another problem, and you try this. This is homework. What is that? Sigma 1 by n power p. Sigma 1 by n power p is convergent if p greater than 1, is divergent if p less than or equal to 1. Our p series test. You prove this. Okay. And next one more problem here. One more problem. What is that? Summation 1 by n into log n power p. N is from 2 to infinity. Test the convergence. Test the convergent. You also try this. Again, this is homework. And answer is p greater than 1 convergent, p less than or equal to 1 divergent. Less than or equal to 1 divergent. Okay. In particular, when we have to apply this integral test means when f of x is integrable function, then only applying integral test. If f of x is not integrable function, don't apply integral test. Okay. Now next series is D'Alembert's ratio test. Third one, D'Alembert's ratio test. Simply it is called ratio test. Simply it is called ratio test. And the statement is, what is the statement here? Statement is let sigma un be positive term series. Positive term series if limit un by un plus 1 as n tends to infinity. What is that? Un means nth term, un plus 1 means n plus 1th term. What is this? Ratio of nth term and n plus 1th term, and its limit value is L. If limit n tends to infinity, un by un plus 1 is L. First condition is if L greater than 1, then sigma un is convergent series. If L greater than 1, sigma un is convergent. Second one, if L value is less than 1, then sigma un is divergent series. Sigma un is divergent series. And third one, if L equal to 1, ratio test fails. If L equal to 1, ratio test fails. L equal to 1, ratio test fails. See the statement once again. Un must be a positive term series, and there is no condition of decreasing or like that. Just positive term series. And limit of the ratio of nth term and n plus 1th term. Limit n tends to infinity. Un by un plus 1 is L. And this if this limit value L is greater than 1, converge, less than 1, diverge, equal to 1, the ratio test fails. Equal to 1, the ratio test fails. When ratio test fails, what is the next situation? There are so many other methods to apply to solve the given series. Okay, remember this statement. And when we have to apply this ratio test? When the condition is, when the series sigma un contains increasing powers of x. Increasing powers of x means x power 1, x power 2, x power 3, like that. When n increases, the x power must be increased. Increasing powers of x and oblique r choice and oblique r factorial terms. Then apply ratio test. Okay, then apply ratio test. This is the condition to apply ratio test. When series contains increasing powers of x or combination with factorials, then apply ratio test. Take one problem. Test the convergence of the series. Test the convergence of the series. 1 by 2 under root 1, x square by 3 under root 2, x to the power of 4 by 4 under root 3, x to the power of 6 by 5 under root 4. 5 under root 4. Okay. Now solution. What is the nth term? Nth term is un equal to, see, the first term, 1 is nothing but x power 0. First term x power 0. See, first term I'm writing only numerator. This is the term x power 0. Second term is what? X square. Third term is what? X power 4. X power 4. And fourth term is what? X power 6. So what is the nth term? Nth term numerator. Actually, all these powers are even, right? All these powers are even powers.
2n
Even
minus
powers
2.
means what?
X power 2.
Actually 2n, even powers. But starting with what? 0. Therefore, n is always start with 1. So this must be x power 2n minus 2. Whole by, what is this one? In the first term, 2 into under root 1. In the second term, 3 into under root 2. So in the nth term, n plus 1 into under root n. N plus 1 into under root n. Any doubts? Okay, this is my nth term. Now this nth term, see, in the series, what is the model? Yes?
Sorry, sir, can we neglect the
Yes.
first term because it's finite, right? So we can we like remove that first term and
Yeah,
just
you can do.
continue from
Yes, you can. See, always remember, you can neglect, but when it is possible to write the nth term, why you have to neglect?
Okay, sir. Okay.
Yes?
Okay, sir.
ఇప్పుడు మీ క్లాస్లో ఫ్రెండ్స్ ఉంటారు, మీరందరూ ఉంటారు, పక్క బెంచ్ అమ్మాయి వచ్చి నీతో ఫ్రెండ్షిప్ అడుగుతుంది, ఎందుకు నెగ్లెక్ట్ చేయం కదా, కలుస్తాను నీతో అంటే కల్పించుకుంటావు కదా. సేమ్ లైక్ దట్, డోంట్ నెగ్లెక్ట్. ఇఫ్ ఇట్ ఈస్ సమ్వాట్ ఏదైనా ప్రాబ్లం ఉంటేనే మనం డెలీట్ చేస్తాం. ఇఫ్ దెర్ ఈస్ నో ప్రాబ్లం విత్ దట్ టర్మ్, డోంట్ డెలీట్ ఇట్. ఓకే, ఎనీ డౌట్స్?
Okay, sir. Thank you.
Right. Okay, now nth term is over. Now observe this series. What are the powers of x? X power 0, x square, x power 4, x power 6. Increasing powers of x. When increasing powers of x, you must apply ratio test. First thing, don't go for geometric series, p series, or comparison test like that. Directly you can apply ratio test. So this is my nth term. Once again, I'm writing nth term here. X to the power of 2n minus 2 by n plus 1 root n. Then what is this? Is nth term. What is n plus 1th term? Just replace n by n plus 1. That is 2 n plus 1 minus 2 by this becomes n plus 2 and this becomes n plus 1. So what is this? X to the power of 2n you will get here, and n plus 2 under root n plus 1. And what is the comparison test statement, ratio test statement? You have to consider un by un plus 1. So write un by un plus 1. Now un upon un plus 1 is equal to, what is un? X to the power of 2n minus 2 by n plus 1 under root n. By un plus 1 means what? By this actually. So what is this becomes? This denominator becomes numerator by x to the power of 2n. Any doubts? un by un plus 1. Now x to the power of 2n, x to the power of 2n gets cancelled. X power minus 2 will be there, can be written as 1 by x square. And what are the remaining terms? N plus 2 root over n plus 1 by n plus 1 root n. And what I am taking for this ratio, I have to take limit n tends to infinity. You know, whenever n tends to infinity, I have to express the function as 1 by n's. So take n common in numerator and denominator. 1 n common, this is 1 plus 2 by n, 1 plus 2 by n, and n common, this is 1 plus 1 by n. So outside it becomes root n. and here n common, and this root n as well. So what are the cancelled terms? N gets cancelled, this root n gets cancelled. Okay, and next one is let me apply limit un by un plus 1 as n tends to infinity. So limit n tends to infinity 1 by x square of what? 1 plus 2 by n under root 1 plus 1 by n by 1 plus 1 by n. So what is this value? Just you will get 1 by x square. Is it correct? This is the value of L. This is the value of L. 1 by x square is the value of L. Therefore, by ratio test, okay, I will write here, by ratio test, sigma un is convergent. Sigma un is convergent if L value, if L is greater than 1, means what? 1 by x square greater than 1 means x square less than 1. And sigma un is divergent if L less than 1. That is 1 by x square less than 1 means x square greater than 1. X square greater than 1. And ratio test fails. If L equal to 1. That implies 1 by x square equal to 1. That is x square equal to 1. Okay. My conclusions about convergent, divergent finished. Okay. When x square less than 1 convergent, when x square greater than 1 divergent. But when x square equal to 1, ratio test fails. Okay. Now, when ratio test fails, what happened? Let us see now. Now, you have to deal with that case also. When x square equal to 1, again begin. What is the nth term? When x square equal to 1, what is my nth term? X to the power of 2n minus 2 by, what is this? N plus 1 into root n, correct? I can write this as x square whole power n minus 1, correct? N plus 1 root n. And what is x square value? 1 means what is this becomes? 1 by n plus 1 root n. Any doubts? Okay. When 1 by n plus 1 root n, what is the structure of this one? 1 by, I will take root n here and n common. So 1 by n. I will go for comparison test, limit comparison. When x square equal to 1, you can apply that test. So 1 by n power 3 by 2, 1 by 1 plus 1 by n. This is my un. Choose vn as 1 by n power 3 by 2. That implies 1 by n power 3 by 2 means more than 1. So convergent. 1 by n power p greater than 1 convergent. Therefore, limit n tends to infinity, un by vn is what? Limit n tends to infinity, 1 by n power 3 by 2 gets cancelled, and this value 1 not equal to 0 and finite. Therefore, by LCT, by limit comparison test, sigma un also convergent. Okay, now after all these cases, you have to mention, this is compulsory, conclusion. You have to mention conclusion. What is the conclusion? Finally, we arrived at what conclusion? Sigma un is convergent. If x square equal to 1, I'm getting this one, convergent. And x square less than 1, convergent. X square less than 1 converge and equal to 1 also converge. And sigma un is divergent if x square greater than 1. This is the problem. Okay. Just check out once again. Firstly, since the given series is containing increasing powers of x, I have to apply ratio test. I have written nth term and n plus 1th term. Next, take the ratio. Okay, after simplifying this ratio and applying limit, I'm getting L value as 1 by x square. Okay, so by ratio test, I have given the conclusions when L value greater than 1, less than 1, conclusions are given. But when L equal to 1, test fails. That is x square equal to 1, test fails. So when x square equal to 1, again begin with un. Substitute that value in un. Since un value can be written as x square whole power n minus 1 by this, when x square equal to 1, that becomes 1 by n plus 1 root n. And yes, I can solve this by using limit comparison test. I solved this and finally make the conclusions for x square equal to 1, less than 1, greater than 1. Okay, this is one problem based on ratio test. Okay. I will stop here. Please give your attendance.